A machine is set to produce metal rods of length 10 centimetres, with standard deviation 0.5 centimetres. The lengths of the rods are normally distributed. Find the percentage of the rods between 9.5 and 10.5 centimetres. The company owner wants to increase the percentage of rods between 9.5 and 10.5 centimetres to 95%. So he resets the machine. Calculate the new standard deviation. So let x be the random variable, the lengths of the rods produced by the machine. X, as we're producing rods which have to be 10 centimetres, I mean we want to be 10 centimetres, and the standard deviation is 0.5, but we write the variance as 0.5 squared. Right, we want to find the probability that a rod lies between 9.5 and 10.5. Although you don't have to draw a diagram, if you do draw a diagram, it's much easier to understand. So the mean is 10, standard deviation is 0.5, so 0.5 away will give me 9.5, and another 0.5 above 10 will give me 10.5, and basically we want the calculator to calculate that area there. So going to our calculator and then doing a calculation mode, and then pressing menu, number 5, probability, number 5, distributions, and we want normal CDF, we never use the PDF. Okay, we want the lower bound to be 9.5, the upper bound to be 10.5, the mean to be 10, and the standard deviation to be 0.5, okay, and then we press that, and we get an answer of 0.68268. Okay, so it gives me an answer 0.68268. We want that as a percentage, so round that off to three significant figures at 0.682, and as a percentage that will be 68.2%. Right, now x will belong to n10 sigma squared, because we need to calculate a new standard deviation. So therefore we can no longer use this normal distribution. We'll have to use the standard normal curve. So sigma will be the standard deviation we need to calculate or to be found. So using the standard normal curve, then the standard normal curve is z belonging to a mean of 0 and 1. So drawing a diagram is probably essential now. So a mean of 0 on the standard normal curve corresponds to a mean of 10 for our modelling situation. Minus z will be minus 9.5 and z will be 10.5. Now we want that area here in the middle to be 0.95, which means that this here has to be 0.025. So z will be 5 to the minus 1. That means do the inverse tables of 0.025 and 0.95. We know this is 0.025 because this one would have to also be 0.25, and this is like the central area. Okay, and then for we'll need to do 5 to the minus 1 is 0.975. So again, going to our calculator, pressing menu, probability, distribution number 5, and this time going to number 3, inverse normal, want the area to be 0.975. By default, this will be set to the standard normal curve. We won't need to do anything there. And we get an answer of 1.959964. So that gives me 1.95996. So this value here corresponds to 10.5. So this is my z value, this is my x value. Z and x are related by doing x minus the mean divided by the standard deviation. So that means rearranging that, we get the sigma, the standard deviation will be x minus the mean divided by z. So putting in the numbers, the standard deviation will be 10.5 x minus the mean 10 divided by 1.9599. Working that out on my calculator, use the fraction button on your calculator, you get 0.2551. So our new standard deviation will have to be 0.255 centimetres to 3 significant figures. Okay, so this is video shows you how to find the standard deviation given some parameters from a normal distribution. I hope you've understood, and I thank you very much for watching.